Hey, thanks for that introduction. But the real title of this talk is Mistakes Were Made, We Forgot to Do Some Things in 2.0. We're now going to ask your permission to get them fixed in 2.1. We might have to do it again for a 2.2, but we'll see. So that said, what follows is 2. What? What is this? So blockchains are, as a piece of software, they run by lots of people, and it's very important that the nodes all do the same things with the same transaction data. Otherwise, the chain can split, and then you have this uncomfortable question of, oh, my transactions went through on this side of the split, but they didn't on that side, and I'm trying to sell them, and maybe my exchange follows the other side, and it's messy, it's painful, no one likes chain splits. So in order to do a breaking change, where we change the way by which transactions get processed, we have to do a network upgrade, and that is what 2.1 is. Now, that said, the process by which we do network upgrades necessarily involves all of the stakeholders that would be affected by the change in the rules. So for me, the words hard fork are both literally and figuratively four-letter words. We don't use them, we call them network upgrades. This is from a slide back at the launch of 2.0 when we realized some mistakes were made. And it's like, Jude, fix it. It's like, I can't fix it. We have a governance process. We have to follow the governance process. You can't just demand that I unilaterally turn the ship around. That's not the way this is gonna work. So say hard fork one more time. Anyway, what follows is a set of proposals, like nothing can go through without the consent of the Stacks community here. Proposal in 3 parts, changing the way in which stacking works for the better, adding some nice goodies to clarity, and improving the system reliability in a way that unfortunately is a breaking change. And the second half of this talk speaks to the procedure by which we would activate this proposal if the community finds it favorable. So stacking, these are a list of hopefully not controversial improvements that we hope to ship in 2.1 and have already been written but are just waiting for community ratification. First of which is continuous stacking. So if you've ever stacked Stacks tokens before, you know there's the cooldown period. We have to wait a reward cycle. Yeah, that's going away. That's going bye-bye. So instead, we're adding these new methods to the POX contract, stacks extend and delegate stack extend. They let you restack your tokens while they are stacked for some more reward cycles and even change your reward address so that you never have to give up the POX rewards. Another thing that's going away, you might have read Reddit, you might have heard on various developer channels that there's a POX sunset that's in place. Reason for that I can talk about more after the talk because it's kind of long and tedious, but it leads to some interesting incentive problems that thankfully I think we have a good solution for now, but we didn't at the time the system launched. So POX is going to be here forever. There's no sunset anymore. If the community wants to turn it off on a reward cycle by reward cycle basis, they can already do that via the reject POX method in the POX contract. Another goodie we're adding is you can reclaim your tokens if you don't clinch a reward slot with them. So you might have stacked some tokens, and then the minimum stacking threshold goes up at the very last minute. Okay, great, now your tokens are locked. You're not even getting any Bitcoin for them. There's no way today to unlock your tokens in that event. You got to wait for however long you stacked them for. But that's changing in 2.1. You'll be able to reclaim the tokens that were not locked immediately afterwards via these new methods, stack unlock and delegate stack unlock. And finally, one thing you might have noticed if you try to fix that problem, like if you try to stack tokens, the threshold increases, then you try to add some more tokens to what you've already stacked. There's a step function in place by which you can increment your stacked tokens, and that step is pretty high. So we're fixing it so that now we can do it in a more fine-grained manner. You can just increment it in small amounts. So you can just push yourself over the stacking limit via the stack increase and delegate stack increase methods. So that's fixes for stacking that we hope to ship. Most of them are already written, and of course, this is a proposal. The APIs that you just saw here are subject to community ratification. We're happy to listen to feedback and change them to make them easier. So hopefully those are not too controversial. The next set of upgrades we're proposing are making the Clarity programming language. It's good now, but it could be better. There are some things that we discovered that are somewhat hard to do in Clarity that we would like to make a little bit easier. Chief among them, I think, is making it easier to do things with Bitcoin transactions. You can do them. Like I wrote like a prototype code library that lets you do some things with Bitcoin transactions, but it's expensive. It's not the easiest thing in the world to use. So I have this high-level list of, I know it's lots of tedious data, high-level list of things that we hope to add to the Clarity VM for the 2.1 upgrade. Chief among them, making it so you can query the Bitcoin block hash of any Bitcoin block, not just ones that have Stacks blocks in them. So if you want to do something like determine if a transaction got mined in a flash block, you'll be able to do so in Clarity now. If you want to see whether or not a transaction got mined in a block prior to the 2.0 launch, you should be able to do that as well. Another goodie that we wish we could have added in 2.0, but didn't, is the ability to take a slice of a sequence. So a list, a string, a buffer. That's super helpful if you ever want to parse something, like parse something that's serialized into a byte string and turn it into some structured data. We're also adding, speaking of which, a lot of data you might want to parse through a slice will be, the byte representation of integers. So we're adding an integer codec to the stack, to the Clarity language that lets you convert buffers and integers and strings back and forth to one another. Second batch of updates that will hopefully really help with this are the ability to manipulate principals. There's a principal type in Clarity that represents a public key or a contract address, but there's no way in Clarity yet to construct a principal from its constituent parts, like a version byte, the hash, the name of the contract. So we're adding ways to construct and deconstruct principals to and from their more primitive representations. And finally, one thing that we really should have added but didn't quite realize would be important at the time is the Stacks blockchain already knows what the Stacks to Bitcoin exchange rate is. It can tell that by mining. Like it can look at the miners and see, oh, well, the miners committed this many Satoshis to produce this block and they got this many stacks. Therefore, the exchange rate must be this at this block. Like that, you don't need an oracle for that. We can just expose that directly through Clarity. It just didn't occur to us at the time to do it. So we need to do that via the 2.1 breaking change. Another big slew of updates we hope to make to Clarity are to expose more data from the Stacks blockchain to Clarity. So the Stacks blockchain keeps track of lots of things internally that really could be available in a relatively straightforward way through the Clarity VM, like figuring out the status of the POX smart contract, like what reward cycles, what reward slots does this particular address have? Like what are their transaction IDs? How much Bitcoin did they receive from them? So if you want to do something that involves like pegging wrapped Bitcoin on Stacks back into Bitcoin, you need to figure out how much of that wrapped asset to destroy once Bitcoin gets paid out through POX. This would be a way you can figure that out without implementing some sort of oracle mechanism to tell you. Another bits of information like, can we query just running system information about the Stacks chain? Like what epoch is it in? Are we in epoch 2.0, 2.05, 2.1? We're in 2.05 right now. But maybe your contract needs to behave differently for 2.1. What chain are you on? Are you on a hyperchain? Are you on an app chain? Are you on the Stacks main chain? What type of block formats do we support? Like what are some of the fields in the blocks? These are things that are available to the Clarity, to the runtime system, but could be exposed to Clarity. They just aren't right now. And finally, one thing we forgot to add in 2.0 is transactions can be sponsored. You don't have to pay your transaction fee. Someone else can pay it for you. They're called the sponsor. We have TX sender as a variable in the Clarity language that tells you who sent the transaction, but we don't yet have a way to know who sponsored it, and that's going to have to get added in the 2.1 release. Third big thing here is easier consumption of off-chain data for Clarity. So if you ever want to like write oracle data to a Clarity contract, or you ever want to parse something that comes from like your application, what we're adding to fix this, and this hasn't been written yet, but it's currently being proposed by Marvin, actually, who's in this audience, I believe, is this way to go to and from a byte buffer, like the canonical byte representation of a Clarity value to the typed representation in Clarity. So you can parse a byte buffer into a Clarity value and do stuff with it, and you can serialize that Clarity value back to a byte buffer so you can do things like hash it or verify signatures over it. And the other thing that's getting fixed, and this was like, we were not happy when we discovered that principal of does not work on mainnet, it works only on testnet. That's getting fixed in 2.1. That's, yeah. Like quoting another developer, we were talking about, they discovered, it's like, God damn it, I hate blockchain programming. Because yeah, you can't change it, when it's already running. You have to wait for a network upgrade. Final thing on Clarity changes, this is more like minutia, that require a breaking change to execute for various reasons. Because there will now be effectively two versions of the Clarity language, like one version with these new keywords and one without, you'll be able to choose which version you want to use in your Clarity smart contracts going forward via a pragma statement. If for whatever reason, like you're in the 2.1 epoch and you don't want the 2.1 features, you'll be able to require that your contract uses the original with Clarity 1.0 features. Other small things like make it so that when you do a contract call, we only bill you for the compressed size load. So right now, if you do a contract call to a very big contract, the runtime cost for that transaction incurs the cost and the read count parameter of loading that contract source code into RAM so you can do stuff with it. Like we should just be compressing these the whole time. That can get you like a 2x or even higher reduction in the runtime cost there. A few other things like a faster parser is coming along. When you do an @block call with a trait implementation, that can let you get around some of the nice safety guarantees that prevent reentrancy, which can be dangerous if you're dealing with code that manipulates your tokens. So we're going to try to make it so you can add post conditions on code blocks that are running inside of an @block. So that way you don't have any sort of weird paths that your code can take that move your assets that you didn't intend or anticipate. And then, small other change, we're going to make the fold operation cheaper by removing some unnecessary type checks. Unfortunately, it has to be done through a breaking change. Second batch of improvements we hope to make in the 2.1 upgrade are making the system just more reliable. Sorry, third batch, more reliable. Fixing some small bugs in the consensus logic that aren't like, show-stopping, but certainly make the system work less well than it could work. The biggest one, and the biggest thing that no one talks about, and I'm glad they don't talk about it because this would be catastrophic if this happened, is suppose that, so in a reward cycle, the way in which we determine who gets paid the Bitcoin, that happens through a POX anchor block, and it's a block that's confirmed by the prepare phase, and that block, the state of the POX contract at the time of that block is used to decide the set of reward addresses. Suppose that block got mined but never got broadcasted. So what the system does now, according to SIP7, is it would revert to using proof of burn. So just no one gets any payout, the miners just burn their Bitcoin, and the system just keeps going that way. But the bad part now is, what if that block shows up later? So what should happen is that block should be ignored, because the network already moved on, it didn't see it at the time, it should be on a minority fork. That's actually not true right now. If that block showed up, there would be a catastrophic deep reorg, whereby all those proof of burn transactions would become invalidated. Hasn't happened yet. If it did happen between now and the upgrade, we would issue a hotfix that just caused the nodes, on a piecemeal basis to just ignore that block. That's not a good thing though. Like, it shouldn't require us having to do that. So we're adding Nakamoto consensus to the history of POX forks, so that if there is a missing anchor block, the system will just recover the way you would expect a blockchain to recover if someone released a block that they mined on a minority fork, i.e. you'd ignore it. The other nice thing about this is that it makes it possible to implement SPV-like light clients where you can rank chain quality based on whether or not the POX anchor blocks are there and how much affirmation they have in the network, and that would let you decide whether or not a particular Stacks fork has more Bitcoin behind it than another Stacks fork, which in turn lets you decide which fork is the best fork without having to go process all the blocks. Big thorn in our side that we didn't really anticipate in 2.0, but are thorn in our side now, are these flash blocks. So Bitcoin blocks arrive on average once every 10 minutes, but that can be as frequent as once every few seconds or once every few hours. So in the few seconds case, that's kind of bad if you're a miner, because that means your block commit transaction might not get picked up in that flash block. It might get bumped to the next one, which causes it to be invalid, meaning you just wasted your Bitcoin. It also means that you might get penalized in the sortition function that chooses the winner, because if you don't go for a consistent period of time mining, you have a lesser chance of winning despite how much Bitcoin you're burning, because the system encourages miners to mine consistently as opposed to opportunistically. Changing this is a breaking change, though. We hope to do this as in this upgrade, and that would just make miners' lives easier. We would also make it so that when we choose the POX anchor block, we have a bit better tolerance for flash blocks in the prepare phase, lest the anchor block not get enough confirmations for POX to begin in the next cycle. Hasn't happened yet, but I would like it if it just never happened. Other minor improvements, there's a really fun little bug we discovered 6 months ago, where if there's an odd number of POX reward slots, no one can win that block, the last block in the reward cycle. Oops. I don't know what to tell you about that one, folks. That's my bad. We will get that fixed in 2.1. There's another couple small things, like if you make a contract call in Clarity now, and if you put the wrong number of arguments on, the type checker won't catch it, but it will be caught at runtime, and the transaction won't be mined. But it should have just told you in the first place. So we're getting that fixed in the type checker. And then finally, we're going to hopefully make it so that you can specify a more diverse set of addresses as your POX reward address. Not the standard P2PKH, P2SH addresses, but also native SegWit, and now that Taproot's around, a Taproot address. This is something we have to investigate a bit more to see how feasible it is, but really hope to add it because that would make doing things like pay Bitcoin to many people more feasible, which in turn makes it more feasible to build decentralized mining pools. So I know it's kind of a lot of information at once. This is all being recorded. You can all watch it after the fact over and over again, and I'm happy to take questions after it. So how do we get this over the finish line? How do we launch this rocket? And I really do mean rocket in an almost literal sense. Launching a hard fork, a network upgrade, whatever you want to call it, on a blockchain is a lot like launching a rocket. You get one chance. And if it fails, it fails. It fails badly. So you don't want it to fail. So you want to make sure you test it really, really well. It's okay to shift the launch date by a few days, a few weeks if need be, in order to make sure the thing doesn't explode when you launch. But the way in which we design the activation procedure, we actually have that grace period just built in natively. So the way in which we do breaking changes, or really any sort of consequential changes to the way the blockchain works, is through an off-chain governance process called the Stacks Improvement Proposal process, or the SIP process. This flowchart here is just an overview of the procedure by which you can get a proposal ratified and accepted by the network and incorporated into the way the blockchain is supposed to work. So every SIP, including the SIP that will describe this 2.1 upgrade, starts out as a draft, and it goes through multiple levels of review through different phases, like the accepted phase, recommended phase, the activating phase, where it passes muster through people with different levels of expertise and different considerations before it's ready for the broader community to decide whether or not it should go through. Now, the thing I want to draw your attention to is this activation section here. It's the last step before getting your SIP ratified. In a breaking change like this one, and we have done this before with the 2.05 network upgrade, the community as a whole, the people who hold stacks, the people who interact with stacks, will have the ability to vote yay or nay on the upgrade, and that is a necessary criterion for this particular SIP activating. There must be sufficient support from the broader community for any sort of hard fork to happen. Developers can't just unilaterally force it through. That's not the way we work around here. We got to make sure everyone who's affected by the change has a way to say yes or no to it. So I mentioned these multiple levels of review. Just briefly what they are, we have 3 categories of reviewers, which anyone in here is allowed to join and participate in. We're happily taking members for everyone. There's the SIP editors, who just make sure that the SIP is, makes sense, it's the right venue, it's well-formed, it talks about all the right things. Anyone can be a SIP editor. There's consideration advisory boards. So every SIP has one or more considerations, like a technical consideration, a consensus consideration. There's also like an economics consideration, an ethics consideration, an inclusion and diversity consideration. It's very broad considerations. We can add more considerations. But anyway, the consideration advisory boards are just meant for individuals who have domain expertise in one or more of these areas to be called upon by SIP authors to review their SIPs and make sure that they pass muster. They pass according to whatever consideration they have. For this particular SIP, the 2.1 SIP, that would be both technical consideration as well as a consensus consideration, and possibly an economics consideration to make sure everything's going to work out. We think it will. But the point is we have this necessary peer review on the SIPs before they have a chance to even get ratified. The second layer of review is the steering committee, and that's run by the foundation and the community. We have both the foundation steering committee as well as community liaison. We have the governance working group. Their job is less to say yay or nay and more to just make sure that all the procedures are followed. And then finally is the stakeholder vote here that I alluded to earlier, which will be a requirement for the activation section for the 2.1 SIP. It will be the steering committee's job to make sure that voting procedure is followed, and it will be up to them to make sure that the procedure is falsifiable so anyone can see whether or not the SIP is passed. And then it'll be their job to just say, okay, yeah, we can declare this done. It's great. Let's go ahead and launch it. We've already done this once before in 2.05, so it's not like this is a brand new process. And what we hope to get done for this SIP is this document will describe all of the features, all of the specifications that any reference implementation must meet in order to be considered a Stacks 2.1 node. So until that SIP is written, that SIP's the final document of what's going into the upgrade. So until that SIP is written, everything I just said is just a proposal. So how do we activate this? So what we're thinking about doing right now, we have a pull request open from Pavitra, from Hero, that will make this happen, is we have a smart contract we'll be publishing called a vote to exit contract. We will release a version, when I say we, I mean the foundation and Hero and anyone else who wants to participate. We will release a node that looks at the state of the smart contract to decide whether or not and when for the Stacks 2.05 nodes to all stop in order for the 2.1 nodes to start up. So right now, if you ever run a testnet node, there's this notion of an exit at block height. So that causes the testnet to reboot. It's basically that, but you can vote on what that block height is on this contract on mainnet. So when this pull request is accepted, this will be part of the ratification process for the SIP. When the 2.05 node, we'll release a version of the 2.05 node that looks at this contract and knows to stop processing blocks if enough people vote for the system to exit. Miners will upgrade to it, and we'll basically have this we'll basically have transitioned the 2.05 network to the point where it has this decentralized kill switch in it that only the set of users of the Stacks blockchain will be able to control. So users decide when this upgrade happens. In parallel to working on this exit procedure, I must emphasize again, the SIP process, not the code, is what determines what's going into the 2.1 upgrade and whether or not a reference implementation is compliant with it. The 2.1 implementation will be finalized, and it will be set up on a 2.1 testnet so we can verify that the thing works live. We'll have a dress rehearsal for the upgrade procedure, et cetera. And we'll make sure that the implementation, which is curated right now by the Stacks Foundation, the reference implementation, gets the relevant sign-offs from the consideration advisory boards and from the steering committee as criteria for the activation. So once we have that 2.05 network upgraded with the vote to exit contract, and once we have the 2.1 node ready to go, we will leave it to the community to decide when that happens. The way it's built right now is community members vote for a reward cycle that is at least 3 reward cycles in the future. The earliest reward cycle they'd be comfortable for the network upgrading. So like it's reward cycle 30 right now. You can vote for reward cycle 33 or later. And then whichever one gets a certain amount of support or more will be the one at which the 2.05 network will stop, and all the 2.1 nodes, which up until then will run with 2.05 rules, will switch over to using the 2.1 rules. And so the upgrade will be pretty seamless, and the risk of a chain split is minimized. So the 2.05 nodes will stop running. 2.1 nodes will start running, and everything should be just fine. People will have upgraded to 2.1 nodes before this happens. All this is coordinating here is just when the new rules take effect. So the 2 URLs I just want to leave you with here. If you want to follow along, participate, send pull requests, leave comments, help us implement it. First URL is the SIPs repository. This is SIP 15 right now, which describes some of the upgrades that you just saw here. We need to flesh that document out and add the rest. And finally, the reference implementation curated by the Stacks Foundation is at stacksnetwork/Stacks blockchain. And of course, we take PRs. We love having new contributors. So please feel free to participate however you would like. Thank you.